friends, good to see you all once again. Today we'll be starting with one more topic of science related to electric current. I hope you have gone through my earlier videos. If not, please scroll down for the link. Today we'll be starting with effects of electric current. There are three effects of electric current: the heating effect, the magnetic effect, and the chemical effect. Today we'll be concentrating on the magnetic effect of electric current. We all have come across this maglev train. Maglev is a short form for magnetic levitation, and this train works on the concept of repulsion property of the magnet. We all know magnet has two poles, the north pole and the south pole. Also, the north and the south pole, that's the opposite poles, they attract each other, while the like poles, they repel each other. And because of this repulsive property, the train appears to be floating. But these magnets are not the permanent magnet. They are created by the principle of electromagnetism. Also, the magnetic cranes, which are generally used for separating the iron scrap from the heap of garbage. Here also, the magnet that is used is based on the principle of electromagnetism. And even the speakers that we have at our home. Going back to the history of the magnet. This place called Magnesia, which is a small state in Asia Minor, that's Greece, a Chinese invader came across a stone which was showing the attraction property towards the iron object. And also when this stone was suspended freely, it always points in the north-south direction. Later on, this stone became used for navigation purpose. And that's how the magnet was discovered. Now we all know that the bar magnet has two poles, the north pole and the south pole. Now if I break this magnet into two pieces, each piece will again have the north pole and the south pole. Now further, if I break down them into more smaller pieces, even those smaller pieces will have the north pole and the south pole. And even if I crush this magnet into a form of powder, each atom of this magnet will have a north pole and a south pole, which means that a magnet is always dipole. You can't separate the two poles of the magnets from each other. Now coming to the magnetic field that is created around a magnet. First of all, a magnetic field is a region around the magnet where the strength of the magnet is effective. Let us see the kind of magnetic lines that are created around the bar magnet. Here, as you can see in the picture, there are certain lines that are created around the bar magnet in form of a closed continuous curves. These lines are called as magnetic field lines or the lines of force. There are certain properties related to these lines of force. Let us look into that. The first thing is the field lines, they always emerge from the north pole and end at south pole. But inside the magnet, these field lines will move from south pole to the north pole, and hence they become as a closed continuous curves. As you can see in the picture, these lines are crowded near the poles and they are moving far away at the center part of the magnet. So we can say that the magnetic field is stronger near the poles than the center part of the magnet. That is the reason why these lines get very crowded near the poles. Also, no field lines cross each other. No two field lines will intersect each other. So these were some of the properties of magnetic lines of force. Now coming to the main topic of magnetic effect of electric current. Now this effect was first discovered by the scientist Hans Christian Ørsted in the year 1820. He was the one to discover the radio, TV and the fiber optic. And hence, to honor his work, the CGS unit of intensity of magnetic field is named after him, that is Ørsted. Let us understand how this magnetic effect or magnetic field is created around a current carrying conductor. For that, we just do a small setup of a conducting wire, say AB, which is connected to a cell and a key. And this conductor is placed parallel to a magnetic needle. Now in this first case, as the key is open, there is no current flowing through the wire AB. Hence, there is no effect seen on the needle. Okay, now in the second case, the keys are closed. Now the current is flowing from point A to B. So let us see the effect. Okay, so here we can see the deflection happening in the needle. The needle gets deflected in clockwise direction. Now let's change the polarity of the cell. So now in this case, the current is flowing from point B to point A. So now in this case, the needle gets deflected in anti-clockwise direction. So this proves that as long as there is no current in the conductor, there is no effect seen in the magnetic needle. But as soon as the current starts flowing through the conducting wire, the needle shows the deflection. Also, with the change in polarity of the battery, the deflection in the needle is also changing. Hence, we can prove that the magnetic effect of current is produced because of electric current. Okay, there's a small amount of magnetic field created because of a current carrying conductor. Okay, I hope you have understood the topic. Please like, share it with your friends and do not forget to subscribe. Thank you.